Kia ora e te whānau. Hi everyone, this is Daniel Larsen. I'm talking to you from Auckland, New Zealand on a beautiful sunny day, and today we are going to try and do some front door cache testing. Quickly do some testing while we've got a bit of time in our lunch break and see if we can understand the caching behavior of our front door cache, and also to observe the caching directives that are being returned by our origin service, or not, as the case may be. So let's have a look at the setup here. So this is my test environment. I've created an Azure Front Door and I've created an app service. So the app service is the origin service in this case. So this is our origin, which is hosting our content. It's on a Azure app service, but I put a front door in front of it. So from the user's point of view, you open a browser and make a request to the front door, and the front door is sending that request to the origin, which is the app service. And then that response is going back through the front door and back to the browser where the user can view it. And the opportunity here is we can actually cache that response on the Azure Front Door using the cache, which is like a CDN-like cache on the front door, which is super handy. But to do that, we need to we need to make sure that our origin is configured correctly. So let's have a look and see how we would do that. First of all, I just want to point out one thing, and that is because I'm an operator, so this is me down here sitting on my laptop here in Auckland. I am using a dev console, so I'm going to use curl on Ubuntu console to hit the origin. Now I can do that because I'm allowed by access restrictions on the app service. But this user here, if they try and hit that origin, they'll get blocked by an access restriction. And that's really handy. That means that I can configure the app service to only accept traffic from the Azure Front Door itself. And that means that I can force traffic to flow through the Azure Front Door and make sure that the WAF is being affected, that any other, that my caching is going to be used, and any other protection or features that I want to be used on the front door are going to be used, and no one's going to try and bypass that service. How do I do that? Well, what I do is I set up access restrictions in the front door. Now, for bicep infrastructure as code nerds like me, of course, I would specify this in a bicep template or using Azure CLI. However, it's just much easier to show you visually what's going on using the portal. So I'm going to use the portal for now. You can see I've got two resources set up here. This is Hello ASP.NET EUS2. This is an app service running in an app service plan. This is a P1 V2, which is pretty cool. And then I've got this front door. This is a front door premium because I've been playing around with the WAF, which is also very cool. So these are the two resources that I've got set up in the portal. On the app service itself, if I go down to the networking tab, you can see where I've set these access restrictions, and there's a beautiful UI around this now. So access restrictions are shown on the inbound traffic side, and I can go and see what those access restrictions are, and they're very easy to configure as well. So here are the rules. It's actually a very powerful rules engine where I've got a rule at 100 which says allow traffic from this IP address, which is where I'm sitting now in Auckland. And this is rule 1110 is saying also allow traffic from the front door, but anything else will be denied. So it's important that any unmatched rule condition is denied. Is the configuration for that. So anything falls through to this low priority rule, I guess, where any unmatched requests are denied. So let's look a little bit closer at this front door access restriction rule. If I click on it now, I can see in the editor that I have restricted this by a service tag. So a service tag in Azure is a grouping of IP addresses. These are basically a huge range of IP addresses that are used by the Azure Front Door service. And I'm saying I only want you to accept traffic. This is from the app services point of view from Azure Front Door, from the back ends of Azure Front Door. Now that's great, but remember, Front Door is a massively multi-tenanted service with tens of thousands of customers being hosted on that service. So it's not enough just to say we'll accept traffic from the front door. What we need to do is be more specific. So we can add a X-forwarded host. So this means only accept traffic with this host name, and that's the host name of my Azure Front Door. So I'm from the app services point of view, I'm saying I only want you to accept traffic with this X-forwarded host header. And I can also add this FDID. So an FDID is an Azure Front Door ID, and it is an ID that you can get from the portal. It'll show you that on the front door. In fact, you can also get it from by requesting its properties via ARM. And that allows me to restrict traffic to only this instance of the front door, so that it ensures that this app service is only going to accept traffic from this front door tenant. And by combining those three settings, it allows me to ensure that my app service origin is secure. So pretty cool, nice and easy. Let's just quickly demonstrate that. So first thing I'll do is I will hit the origin. So this is helloasp.net. It's on an Azure Websites.net hostname, so you know that this is an app service. If I curl this now from my developer machine, I should be able to hit it, because as you saw before, we've got an allow rule allowing my IP, and yes indeed, I get an HTTP 200 on that. If I do that from anywhere else, and a nice and a cool trick for doing that is do it from the Cloud Shell, is I do it from the Cloud Shell, I can curl that. It's the same address now. It'll be from a different IP address, and I'm expecting to get a 403 IP forbidden, and indeed I do. And you can see here's the IP address that is forbidden on, and that is going to be an internal Azure IP. So it's not letting anyone else in. That's great. Let's just have a look at that visually again. So traffic from my dev console is allowed to flow to origin. From a user, it's not allowed to go directly to origin, has to go via the front door. Let's just check that now. So let's hit the front door. Here it is, hello WAF dash big long URL. Make a request on that now. I get an HTTP 200. That's good. If I try and do the same thing from the Cloud Shell, then I should also here we go. So this is a request to hello WAF dash big long URL. This is on azurefd.net. And I can hit that one fine as well. So that's proved the positive of that rule. All good. We're ready to start testing now. Our environment's all set up and secure. Cool. So let's make a request from here and see, first of all, what caching directives is this app service already returning. So this is important because Azure Front Door will honor the cache directives that are returned from the app service. Let's drill into that a little bit deeper. So let's go into our front door configuration here and go into our endpoints. This is the one I want. And you'll see on my route configuration that caching is enabled. Let's clear the console and make a request to our origin. This is it, azurewebsites.net. Great, so we can see HTTP2, this is a 200 response, content type header, date header, server header, cache control is private. So what does cache control private mean? Well, if we look for that in this document, you'll see cache control response headers that indicate that the response won't be cached, such as cache control private, are honored. That means that it's going to cache it. It's not going to cache it no matter what. So now let's hit the front door and see what front door is going to do about that. So let's hit the front door. Remember, this is making a request, passing this request on to the origin. And if it says a cache control private header, it honors it. So it also passes it through back to the client. But you can see from the xcache header, which is a special header for diagnostics that's returned by front door, you can see it said private, no store. What that means is I'm never going to cache this content because the origin has told me not to. Now, that could be good or bad, depending on your point of view. In this case, it's bad. I actually want this content to be cached, and I want to have control over how it's cached. So I've set up a handy dandy test website here. Let's have a look at it. So here it is. Here's HelloWAF, azurefd.net in all its glory. It's a very simple site that I made for testing the source codes here. It essentially just returns a bit of information about the site. And what I can do is I can configure this using app settings on the app service itself. So I'll show you what I mean there. Let's close that, go into configuration. While we're waiting for that, let's have a look at the docs. So there's docs here about these app settings, and one of them is cache control header value. So when I specify this, it'll return this cache control header to whatever I set this value to be. It'll return that in the response. So you'll see that I'm using that right now. If we go into cache control header value, it's currently set to private. I've set it to do that. Now let's remove it. So we're just going to remove that. We're going to save it. We're going to continue. It's going to update those settings. It'll take a few seconds for that to update while the app service restarts, because it does restart when you change settings. And then once it's restarted, then I will be able to curl that app service and see if its cache control header has changed. You can see the last time I queried the origin that it returned cache control private. And we saw the implications of that. I'm just going to have a sip of cup of tea. Right, hopefully it's done its thing now. Let's see if we've made that change. Yes, so we've changed the configuration. I've removed the cache control header by setting its value to an empty string. So that means that my origin now is no longer returning any cache control header. So this is from the point of view of my origin now. This is its response. There is no cache control, no directive in here, no expires header, nothing that's going to tell front door how to cache it. So what is front door going to do now? Well, let's hit it and find out. So now front door says, right, I've made a request. There's no cache header, and my xcache is a miss. TCP miss means that I haven't been able to retrieve this request out of cache. But the second time that I do it, I should get a hit, right? And indeed I do. You can see that request came back really quickly, and we've got a TCP hit now. And that's because I haven't specified a cache control header. And now front door is caching this item for anywhere between 1 and 3 days. So that's great. Caching is working. But the downside is this content, so the front page of this website, so this one here, isn't going to change for 3 days or for up to 3 days. And you can see that every time I make a request, you can see that that's a number there that should be incrementing, is not changing at all. UTC now is still stuck on 420 UTC time. There's nothing going on. And that's great. It is caching, but it's now completely out of my control. What if I want to change the content of this site? What if I don't want it to be cached as aggressively? Those types of things. I actually really want control of the caching behavior, and I want to be able to set that from the origin. So the way that I do that is I configure the origin to return a cache control header. You can do this in code. There's loads of different ways to do this. I'm using a configuration setting, but this is because it's a test app. But if you look in popular frameworks like ASP.NET, Google that, you'll be able to quickly see how to set a cache control header. So what I'm going to do now is I'm going to change this to a more sensible value, and I'm going to say this is going to be max age equals 60. Max age equals 60 means I want you to cache this content for up to 60 seconds. And realistically, in reality, it will cache it for 60 seconds. So that means I want you to cache this content for a minute. So I'm going to save that. It's going to reboot the app service as well. Now, of course, I've got that response in the cache on the front door. So what I need to do now is purge the cache on the front door so that it purges the cache so that I can test the caching again. So I do that, I just go purge cache. This is not something you'd do a lot on a production system, especially if it's extremely busy. Be very careful about this. This is just a test system. There's only me hitting it. There's only one page essentially that's serving it. So I'm fine to purge all of the assets for that domain. So that's what I'm doing now. That can take a few minutes. So yeah, don't expect purging to be instant. It has to go and purge your content from 200 plus pop nodes. So it can take a little while. But once it's taken place, we should see a change in caching behavior. So let's have a look. Let's go back and make a request now from the app service, and remember this is our origin. So remember we've changed the cache control header. We should see that returned in this response, and indeed we do. There's cache control max-age equals 60. This is a directive to any upstream proxies, including front door and browsers, to say you can cache this content for up to 60 seconds. That's fine. Now let's make a request from the front door itself and see what it does. Cool, so it's returned our cache control header. It's a TCP miss because we've purged the cache, and now that content has been cached, I should be able to hit it again and get a TCP hit. And the reason why that's worked is because I've done it within 60 seconds. So here is that max age equals 60. So this is the TCP miss. This was on the 22nd of December at 4:23:18. Now, if I wait until 4:24:18, I've got about 30 seconds left to do that, then we should see that now that content is, that cache item is expired. So I'll do it again now. I'm not expecting it to be expired. It's still a hit. It's at 4:24:1. Remember, we want it to go 4:24:18. So let's do it again. 4:24:08, still getting a hit. 4:24 still getting a hit. Try and sneak in one more. 4:24:16, still a hit. Right, time has elapsed now. 60 seconds has definitely elapsed now. And indeed, we get a TCP miss. So that's the caching in action there at 4:24, which is about 66 seconds after the original cache request. You can see now we've missed the cache and it's gone and refreshed that content. This page has got a TTL of 60 seconds, so time to live of 60 seconds, that response, or an expiry time of 60 seconds. That's a pretty useful expiry time, because it means that if we do want to update the homepage of our website, we don't have to wait any more than a minute for that to change, which is really cool. So there we go, really nice simple demonstration of caching in action and why setting those cache control headers is so important and having them in place, and how you can change the behavior of front door caching by returning the proper host headers from the origin. Just one more thing to show you. If we open up, oops, not that guy. If we open up Developer Tools in our browser, then we can also see this type of behavior by looking at the network tab. So I've been using curl. You do the same thing by refreshing, by opening up Developer Tools in Edge or Chrome, and you can see here the cache control header there, and you can also see our TCP hit. Hopefully it's expired by now. If we do it again, that's still a hit. We wait a few more seconds. So keep an eye on that number there, 8107. There we go. It's incremented by 1. That means that's gone all the way back to origin. And we can see TCP miss with a cache control max age 60. The next one now, keep an eye on that number, 108. If I hit refresh, it's the same response. It's being cached. We can validate that by looking at Xcache as TCP hit. Pretty cool, eh? So that's caching. Now, the real advantage of this, if you read my latest blog on the Fast Track blog about using caching to help mitigate or help protect or defend against DDoS attacks. What this allows us to do is make sure that our app service doesn't get swamped by malicious actors sending us thousands and thousands of requests per second. If we push a lot of those back to cache, then it makes it a lot harder for an attacker to try and take our website down. So if you're interested in that, have a read of that blog. Let me know any questions in the comments. Love to hear from you, and hope you have an awesome day. Kia ora koutou. I'll see you later, and thank you so much for listening. See ya.